Quiz 6 sample. In number 1, we are asked to compute the determinant. So we got 4 rows and 4 columns. Now we can expand with respect to any row or any column. So we want to choose the row or column that contains most zeros. And looking at this, we can clearly see this row, this column. So we can expand along third column. Okay, so you don't have to write this, expand along C3, third column. So this determinant is equal to, now we need to look for the sign. So plus, always write plus, minus, plus. So the cofactor will have plus sign. So 2 times. Now we delete the row and column containing that leaves 0, 3, negative 4, negative 5, negative 8, 3, 0, 5, negative 6. Okay, and we don't have to expand along others because 0, 0, 0 is going to be 0. Now we still need to determine this determinant of a 3 by 3 matrix. So again, we want to expand along a row or column, and obviously 0, negative 5, 0, so we want to expand along first column. Okay, so this is to outside, and we are doing expand along column 1. So this is plus, minus, plus. By location this is plus, nothing, minus, times minus, the element is negative 5, the cofactor will have minus sign, and again we delete the row and column containing that element. So 3, negative 4, 5, negative 6, and 0, don't have to do it. So this is 2 times negative and minus plus, 2 times 5, 10, and we know how to determine this determinant. Just 2 by 2, it's easy. 3 times negative 6, negative 18, minus 4 times 5 times negative 4, negative 20. So 10, that's plus 20, 20 minus 18, 2, 10 times 2, 20. Okay, so the determinant is 20. For this, see the website. Here, determine if each of the following is true or false. Okay, and justify your answer. So if this statement is false, then we provide a counter example. It says A and B are 2 by 2 matrices, and then determinant of A plus B is same as sum of determinants. We know that determinant of product is product of determinants. Okay, that's the theorem, but I'm not sure about this. Let's see, A and B, we can combine these two and make 0 matrix, and determinant of 0 matrix will be 0, but the individual determinants could be different, so this will be false. Let's try A with, so I want to pick A and B so that A plus B is 0. Okay, let's say 1, 0, 0, 1, and negative 1, 0, 0, negative 1. So the determinant of A is 1, determinant of B is again negative 1 times 1, 1. But okay, so let's find the determinant of A. Determinant of A is 1 minus 0, 1. Determinant of B is negative 1 times negative 1, 1. But if we add A and B, so 1 minus 1, 0, so this is a 0 matrix. Then determinant of A plus B, this is just 0. Okay, that means the determinant of A plus B is not equal to determinant of A plus determinant of B. this one right hand side, if you look at here, so for our example we got 1 1 1 plus 1 2, and we got here 0. That's why this is a false statement. Okay, now A and P are 2 by 2 matrices with P invertible. That means inverse exists, or determinant of P is not 0. Then this is the case. Okay, it's a product, and we know that a determinant of product is sum of determinants, and looks like it's gonna work. So let's try to prove this. Okay, so determinant of, I'm gonna say true, P A P inverse is, so we got a product of 3 things, so still we can write sum of 3 determinants. So determinant of P plus determinant of A plus determinant of P inverse. Okay, oh my bad, determinant of product is product of determinants. Okay, look at here, this is not sum, I mean sum is false, so I meant this one. Now we are supposed to get, we started from left side, now we are trying to get to determinant of A. Look at here, determinant of P inverse, we know that that is same as 1 over determinant of P. So this is determinant of P times determinant of A times determinant of P inverse is 1 over determinant of P. That's one of the theorems. Okay, then this one cancel, that leaves what, determinant of A. That's what we have in the right hand side. So from the left side, we started from the left side and we got to the right side. That's why we claim that's true. So when it's true, we need to prove. When it's false, just provide one example. Okay, now compute the adjugate or adjoint of the matrix and find the inverse. Okay, so we need to find the inverse by finding the adjugate. So we got A11, I mean this is A11, A12, A13, etc. Now we want to find the corresponding cofactors. Okay, C11, C12. So let me find that. So C11 will be, we always start with plus minus plus minus. Okay, so here is first is plus. Now we delete the row and column containing that leaves 0 1 1 2. Okay, and we will find this is 0 minus 1. And now let's find C12. So based on A12, this is C12 by location plus minus, this will be minus. Now we delete the row and column containing this one, so 1 1 0 2. Okay, which is 2 minus 0, just 2, and negative 2. So I'm gonna find all 9 cofactors here. So in this way we find 9 cofactors, all of them here. Then now we need to find the determinant of A, and then determinant of A is, we can expand along any row or any column. Let's expand along first column. So that's 2, that's A11 by the way. So we can write in this way, A11, the corresponding cofactor C11, plus, we are going this way, right? This is A11, A21, C21, plus third is 0, so we don't have to even write because it's going to be 0. And A11 is 2, C11 we found here, that's negative 1. A21, that's 1, C21. Okay, C21 is found here. Now we put negative. okay, because that's the negative, that's why this negative, so it comes out to be just positive 1. So negative 2 plus 1, so negative 1. So determinant of A is negative 1. Now we can find the adjugate of this matrix, which is ADJ. Adjugate of A is just the matrix, writing C11, C12, but we need to transfer C12 here, C13, C21, C22, C23, C31, C32, C33, okay, which is just from here, that's negative 1, then negative 2, 1, here is 1, 4, negative 2, 1, 1, negative 1. So we have adjugate of the matrix A. Then A inverse will be just 1 over determinant of A times this matrix, adjugate of A. So we multiply each entry by 1 over determinant of A, and we have found determinant of A to be negative 1. So we multiply by 1 over negative 1, which is just negative 1. So we multiply each entry by negative 1. So negative means this becomes positive, positive, now negative, 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 positive, negative, negative, positive. Okay, and here find the area of the parallelogram whose vertices are listed. So if we draw here, 0, 0 would be here. Okay, that's good because it's in the standard position now. Negative 2, 4, negative 2, 4, somewhere here, and 4, negative 5, 1, 2, 3, 4, negative 5, 4, negative 5, okay, 4, negative 5, this is negative 2, 4, and 2, negative 1, so 2, negative 1, okay. So I don't know how to draw this, let me see. So the graph somehow looks like this. Okay, it doesn't have to be exact. The good news, this is in standard position 0, 0, and negative 2, 4 plus 4, negative 5 is gonna be 2, negative 1. So this is 2, negative 1. So these are the two adjacent sides. So we just use these 2 points because sum of these two, look, negative 2 plus 4 is just 2, and 4 plus negative 5 is negative 1. So this is 2, negative 1. That means we need to use these two coordinates to find the area. Okay, so we have the matrix, which is now, doesn't matter which one you write first, negative 2, 4, and 4, negative 5. Now we can find the determinant. Negative 2 times negative 5 is 10, minus 16 is negative 6. So area will be just absolute value of this, which is 6.